Maths Olympiad Class 9. Number System.
Natural numbers 1, 2, 3, 4, etc. are called natural numbers denoted by n. Whole numbers. All natural numbers together with 0 are called whole numbers denoted by W. W is equal to 0, 1, 2, 3, 4 and so on. Integers are denoted by Z. -4, -3, -2, -1, 0, 1, 2, 3, 4 and so on. -1, -2, -3, -4, etc. are called negative integers. 1, 2, 3, 4, etc. are called positive integers.
Fractions. The number of the form x by y, where x and y are natural numbers, are known as fractions. Example: 3 by 5, 2 by 1, 1 by 125, etc. Rational numbers q. A number of the form p by q, that is, q is not equal to 0, where p and q are integers, is called a rational number. Example: -3 by 17, 5 by 19, 10 by 1, -11 by -23, etc. A rational number p by q is positive if p and q are either both positive or both negative. Example: 3 by 5, -2 by -7. A rational number p by q is negative if one of p and q is positive and the other one is negative. Example: -5 by 9, 7 by -23. Properties of rational numbers. If p by q is a rational number and m is a non-zero integer, then p by q is equal to p into m by q into m. Example: let us take 3 by 4, a rational number, and m is equal to 2, 3, 4, which are non-zero integers. Then 3 by 4 is equal to 3 into 2 by 4 into 2 is equal to 3 into 3 by 4 into 3 is equal to 3 into 4 by 4 into 4 is equal to, and so on. If p by q is a rational number and m is a common divisor of p and q, then p by q is equal to p divided by m by q divided by m. Example: let us take -36 by 48, a rational number, and m is equal to 12, 6, 3 and so on, which are common divisors. Then -36 by 48 is equal to -36 divided by 12 by 48 divided by 12 is equal to -36 divided by 6 divided by 48 divided by 6, that is equal to -36 divided by 3 by 48 divided by 3 is equal to, and so on. Two rational numbers are equivalent only when the product of the numerator of the first and the denominator of the first and the numerator of the second. Thus, p by q is equal to r by s only when p into s is equal to q into r. Example: -15 by 8 is equal to 5 by -6. -15 into -6 is equal to 5 into 18, that is equal to 90 is equal to 90. So they are equivalent. Standard form of a rational number. A rational number p by q is said to be in a standard form if q is positive and the integers p and q have no common divisors other than 1. Example: x plus 22 by -77 in a standard form. 22 by -77 is equal to 22 into -1 by -77 into -1 is equal to minus 22 by 77. That is, denominator is positive. Now find LCM of 22 and 77. It is 11. So, divide both the numerator and denominator by 11. That is, minus 22 by 77 is equal to minus 22 divided by 11 by 77 divided by 11 is equal to minus 2 by 7. Therefore, minus 2 by 7 is the standard form of 22 by minus 77. Comparison of two rational numbers. Step 1. Express each one of the two given rational numbers with a positive denominator. Step 2. Take the LCM of these positive denominators. Step 3. Express each rational number with this LCM as common denominator. Step 4. The number having greater numerator is greater. Example. Which of the two rational numbers 2 by minus 3 and minus 4 by 5 is greater? Step 1. 2 by minus 3 is equal to 2 into minus 1 by minus 3 into minus 1 is equal to minus 2 by 3. Minus 4 by 5 is already in the standard form. Step 2. LCM of 3 and 5 is equal to 15. Step 3. Minus 2 by 3 is equal to minus 2 by 3 into 5 by 5 is equal to minus 10 by 15. Minus 4 by 5 is equal to minus 4 by 5 into 3 by 3 is equal to minus 12 by 15. Step 4. Since minus 10 is greater than 12, minus 2 by 3 is greater than minus 4 by 5. Three important properties of a rational number are: for each rational number x, exactly one of the following is true. X is greater than 0, x is equal to 0, x is lesser than 0. For any two rational numbers x and y, exactly one of the following is true. X is greater than y, x is equal to y, x is lesser than y. If x, y, z be a rational number such that x is greater than y and y is greater than z, then x is greater than z. Addition of a rational number. To add two rational numbers with the same denominator, we simply add their numerators and divide by the common denominator. Example, minus 5 by 7 plus 1 by 7 is equal to minus 5 plus 1 by 7, that is equal to minus 4 by 7. When denominators of given numbers are unequal, we take the LCM of their denominators and express each one of the given rational numbers with this LCM as the common denominator. Now add as shown above. Example, minus 3 by 8 plus 5 by 4. LCM of 8 and 4 is 8. Minus 3 by 8 is equal to minus 3 by 8 into 1 by 1, that is equal to minus 3 by 8. 5 by 4 is equal to 5 by 4 into 2 by 2 is equal to 10 by 8. That is equal to minus 3 by 8 plus 5 by 4 is equal to minus 3 by 8 plus 10 by 8 is equal to minus 3 plus 10 by 8, that is equal to 7 by 8. Alternate method, minus 3 by 8 plus 5 by 4. Minus 3 into 4 plus 5 into 8 divided by 8 into 4 is equal to minus 12 plus 40 divided by 32. That will give you 28 by 32, that is equal to 7 by 8. Subtraction of rational numbers. If a and b are any two rational numbers, then we define a minus b is equal to a plus the whole of minus b. Thus, subtracting a rational number means adding its additive inverse. Multiplication of rational numbers. Product of two rational numbers is equal to product of numerators by product of denominators. Properties. Closure property. The product of two rational numbers is always a rational number. Thus, if a and b are two rational numbers, then ab is also a rational number. Commutative property. Two rational numbers can be multiplied in any order. Thus, if a and b are two rational numbers, then ab is equal to ba. Associative property. While multiplying three or more rational numbers, they can be grouped in any order. Thus, if a, b and c be any three rational number, then a into bc, that is a into the whole of bc is equal to ab the whole into c. Identity property. The product of any rational number with 1 is the rational number itself. Thus, if a is any rational number, then a into 1 is equal to 1 into a is equal to a. Note, 1 is called the multiplicative identity for rational numbers. Distributive property. If a, b and c are any three rational numbers, then a into the whole of b plus c is equal to a into b plus a into c. This is called the distributive property of multiplication over addition. Division of rational numbers. If a and b are integers such that b is not equal to 0, then a divided by b is equal to a into the reciprocal of b is equal to a into 1 by b. Here a is called the dividend, b is called the divisor, and the result is known as the quotient. Absolute value of a rational number. The absolute value of a rational number is the number without any regard to its sign. Thus, for any rational number x, the absolute value of x is equal to mod of x is equal to x if x is greater than 0, 0 if x is equal to 0, minus x if x is lesser than 0. The mod of x plus y is lesser than or equal to mod of x plus mod of y, where x and y are rational numbers. The mod of x into y is equal to mod x into mod y, where x and y are rational numbers. If x and y are any two rational numbers such that x is lesser than y, then 1 by 2 into x plus y is a rational number lying between x and y. Some results on irrational numbers. The negative of an irrational number is an irrational number. The sum of a rational and an irrational number is an irrational number. The product of a non-zero rational number with an irrational number is always an irrational number. Real numbers. The totality of all rational and all irrational numbers forms the set R of all real numbers. Properties of all real numbers. Closure property of addition. The sum of two real numbers is always a real number. Commutative law for addition. A plus b is equal to b plus a if for all real numbers a and b. Associative law for addition. A plus b the whole plus c, that is equal to a plus the whole of b plus c if for all the real numbers a, b and c. Existence of additive identity. 0 is the additive identity. A plus 0 is equal to 0 plus a is equal to a if for all the real numbers a. Existence of additive inverse. For each real number a, there exists a real number minus a such that a plus minus a is equal to minus a plus a is equal to 0. Closure property for multiplication. The product of two real numbers is a real number. Commutative law of multiplication. AB is equal to BA if for all real numbers A and B. Associative law of multiplication. AB into C is equal to A into BC if for all real number A, B and C. Existence of multiplicative identity. 1 is called the multiplicative identity. Existence of multiplicative inverse. Every non-zero real number a has its multiplicative inverse 1 by a. Distributive law of multiplication. Existence of multiplicative identity. 1 is called the multiplicative identity. 1 into a is equal to a into 1 is equal to a if for all real number a. Existence of multiplicative inverse. Every non-zero real number a has its multiplicative inverse 1 by a. Distributive law of multiplication over addition. A into B plus C the whole is equal to AB plus AC if for all real numbers A, B and C. 0 is a real number which has no multiplicative inverse. Real numbers are of two types: rational numbers, irrational numbers. Modulus of a real number is given by mod of x. If mod of x is equal to a implies x, that is equal to plus or minus a. Mod of x is lesser than a implies minus a is lesser than x lesser than a. Mod of x greater than a implies x is greater than a or x is lesser than minus a. Mod of x minus a is greater than L implies a minus L lesser than x lesser than a plus L. Mod of x minus a is greater than L implies x is greater than a plus L or x is lesser than a minus L. If a is rational such that a to the power of 1 by n is called the surd of order n. A raised to 1 by n is equal to nth root of a is a surd. It is also called a radical. Rational number a is called a radicand. Laws of surds. Nth root of a the whole power of n is equal to a. A raised to 1 by n into b raised to 1 by n the whole power of n is equal to ab. A raised to 1 by n into b raised to 1 by n is equal to ab the whole power of 1 by n. A raised to 1 by n by b raised to 1 by n the whole power of n is equal to a by b, that is b is not equal to 0. A raised to m the whole power of 1 by n is equal to a raised to 1 by n the whole power of m is equal to a raised to m by n. A raised to 1 by m into a raised to 1 by n is equal to a raised to 1 by m plus 1 by n. A raised to 1 by mn is equal to a raised to 1 by m the whole power of 1 by n, that is equal to a raised to 1 by n the whole power of 1 by m. A surd whose rational factor is unity is called pure surd. Example: root 3, root 2, cubic root of 4, etc. A surd whose rational factor is any number other than its unity is called a mixed surd. Example: 2 root of 3, 2 cubic root of 5, etc. Surds having same irrational factors are called similar or like surds. Example: root 2, 5 root 2, 1 by 2 root 2, etc. Rational factor, that is RF. If the product of two surds is a rational number, then each is called the rationalizing factor, that is RF of the other. RF of monomial surd a raised to 1 by n is a raised to 1 minus 1 by n. RF of binomial surd root a plus root b is root a minus root b.